Hello everyone. So in this video, we are continuing with topical questions from chapter 3. In this video, we'll be solving all the questions related to chapter 3 from May-June 2024, paper 4.2. So let's start with the first question. First question says, under certain conditions, iron reacts with steam to form an oxide of iron with the formula Fe3O4. Now, this oxide, that is iron oxide, Fe3O4, reacts with dilute hydrochloric acid to form a mixture of iron 2 and iron 3 salts and water. Deduce the symbol equation for the reaction between Fe3O4 and dilute hydrochloric acid. We have to understand one thing, that this oxide of iron is going to be basic. We said it's a metal oxide, and all metal oxides are basic in nature. And this basic substance is going to react with dilute hydrochloric acid. So here a reaction between a base and an acid is happening. So the type of reaction is called as neutralization reaction. When an acid and a base reacts, we call it as a neutralization reaction. And the products formed will be the corresponding salt plus water. Now, the salt will have two ions. One will be the cation and the other will be an anion. So for a salt, there will be a cation and an anion. And the cation will be coming from the base or the metal, and the anion will be coming from the acid. Okay. So since over here, the base is iron oxide, which is Fe3O4, and the acid is HCl, right? So the cation will be the cation of the base, which is iron, Fe. And the anion will be the anion of the acid, which is Cl. Okay, so our salt should contain Fe and Cl as its cation and anion respectively. Now, it is being mentioned that there are two salts formed. One having an oxidation state of 2, and the other one wherein the iron has an oxidation state of 3. So there are two salts, and both the salts are of iron and chlorine itself, but the oxidation states differ. For the first one, it is iron 2 chloride, and the second one will be iron 3 chloride. So we'll see how the formula is going to be. So Fe is there and chlorine is there. In the first case, chlorine has a charge of -1 and iron has a charge of +2 because the oxidation state given is 2 over here. So the formula is going to be crisscrossed and bound. So the formula will be FeCl2 for iron 2 chloride. And if you take iron 3, the formula is going to differ. And we'll see what the formula is. So iron has an oxidation state of 3 over here because it is clearly given in the question that it is iron 3 salt, the next one, right? So iron has an oxidation state of 3, and chlorine, since it belongs to group 7, it will always have an oxidation state of -1. Iron is a transition metal, and that is why it is showing different oxidation states. And chlorine is not a transition metal and belongs to group 7, so it has a fixed oxidation state, which is -1. So the formula will again be found by crisscrossing. So the formula will become Fe1, which we don't have to mention it explicitly. So FeCl3 will be the formula of the second salt. Okay, so let's write the equation now. Fe3O4 plus dilute hydrochloric acid means it is going to be HCl, which will be aqueous in nature, gives FeCl2, that is the salt containing iron 2, plus a salt containing iron 3, which is FeCl3, plus water, which is H2O. Now, this is going to be the equation. We have to see whether it is balanced. Looking at the equation, we can see that the equation is not balanced. So first, we will try to balance chlorine. Over here, chlorine has an odd number, so we'll try to make it even by multiplying it with 2. So the number of chlorine atoms becomes 6 plus 2, 2 is over here and 2 into 3, which is 6 over here. So the total number of chlorine atom in the RHS becomes 8. So we have to make it 8 in the LHS as well. So we multiply HCl with 8 so that the total number of chlorine atom becomes 8. Now, if you see the number of iron atoms, it is 2 into 1 over here plus 1. That is totally the number of iron atoms is 3 in the RHS and 3 in the LHS. So it is balanced. Iron is balanced and chlorine is also balanced. Now we have to check whether oxygen and hydrogen is balanced. So if you see over here, oxygen is 4 and there is only 1 oxygen in the RHS. So we will multiply it with 4 so that the number of oxygen atoms become balanced. And the last one is hydrogen. Hydrogen is 8 in the LHS and in the RHS, if you see, it is 4 into 2, again 8. So now it is balanced. So the equation, symbol equation will be Fe3O4 plus 8HCl gives FeCl2 plus 2FeCl3 plus 4H2O. You don't have to mention the state symbol, that is aqueous, because it is not mentioned in the question. Okay, so this is the answer for the first question. Now, moving on to the next question. The second question says, an incomplete symbol equation for the preparation of ammonia in laboratory is shown. CaO plus 2NH4Cl gives CaCl2 plus dash plus 2NH3. The question is, complete the symbol equation. So we have to understand that this is a reaction between a metal oxide. Again, when it is a metal oxide, the nature of metal oxide will be basic. So a base and ammonium chloride. So a ammonium salt is reacting. So ammonium salt and base is reacting. So let's see the general equation for a base reacting with ammonium salt. So base, when it reacts with ammonium salt, produces corresponding salt, that is the metal salt. What do you mean by metal salt? A salt wherein the cation will be the metal of the base plus ammonia, which is NH3 plus water. So this will be the general equation. And if you see the equation over here, CaO plus NH4Cl, that is a base, plus ammonium chloride salt gives the corresponding metal salt, which is calcium chloride, plus ammonia is also given. So the missing part is water. So we will just write H2O and we have to see whether it is balanced. Over here, there is 8 hydrogen atom, 2 into 4, which is 8 hydrogen atom. And here it is 2 into 3, 6 hydrogen plus 2 hydrogen from water. So it is balanced. 2 plus 6 is 8. So it is balanced. So we'll just write H2O. I hope you understood this. Now let's go to the next question. Name NH4Cl. NH4Cl is a salt that contains NH4 plus as the cation and Cl minus is the anion. NH4 plus is ammonium. So the cation is ammonium. And Cl minus is the anion. So we will call the anion as chloride. Always remember, anions usually end in "ide" for group 7 elements. So ammonium chloride is the formula. Is the name for the given salt. Let's move on to the next question. The next question asks us to calculate the volume of ammonia, NH3, measured at room temperature and pressure, which forms when 1.12 gram of calcium oxide is heated with excess NH4Cl. So we have already seen the equations that we require in order to solve stoichiometric related questions. If you haven't watched that part, that is part 1 of this series, I'll give the link below. You can watch it. So over here, the given substance, it says 1.12 gram of CaO is heated with excess of NH4Cl, which means the limiting reagent limiting reagent over here is calcium oxide. And whenever we are finding out the amount of product formed, we are always concerned about the limiting reagent. Okay, we'll take the limiting reagent and then only we'll solve it. We won't consider excess reagent because excess reagent will be there even after the reaction is complete, but the limiting reagent will be completely used up as the reaction stops. So we will be always looking at the limiting reagent to find the amount of products formed. So over here, we will be using stoichiometric ratio to find the amount of product formed, which is ammonia. Because if we see NH3 is a gas. And for finding the number of moles of gas, we use the formula N is equal to V by 24, where V is the volume of NH3 produced. So if we look at the question, we will not be able to find the volume of NH3 produced. Can you see the question and tell me whether the volume of NH3 is given? Yeah, so the volume of NH3 is not given in the question. So we can't use this formula to find the number of moles of NH3. Instead, what we will use? We will use the stoichiometric ratio method. Okay. In the ratio method, we will be finding out the number of moles of a known substance. So over here, the known substance will be the limiting reagent because the limiting reagent is the one that is going to determine the amount of product formed. So number of moles of CaO is to number of moles of NH3 will be calculated. So in order to find the number of moles of CaO, what formula will be used? We know that the mass of calcium oxide is given, right? So it is in solid state. And whenever something is in solid state, we use the formula N is equal to M by Mr to calculate the number of moles. So number of moles of CaO will be equal to mass of CaO divided by molar mass of CaO. So mass of calcium carbonate is 1.12, which is already given in the question. And MR of calcium oxide is also given in the question, which is 56. So 1.12 divided by 56 will give us the number of moles of calcium oxide, which is equal to 0.02. Now, we will be using the stoichiometric ratio method to calculate the number of moles of NH3. So, according to the ratio method, that is stoichiometric ratio method, we will be calculating the number of moles with respect to the coefficients. Okay, so our limiting reagent over here is calcium oxide, and calcium oxide is going to decide the amount of products formed. So we'll be taking the limiting reagent, calcium oxide, and then finding out the number of moles of NH3 required. So the number of moles of calcium oxide was found out to be 0.02, and we don't know the number of moles of NH3. So we are putting it as X. Now, for finding out the coefficient, we have to look at the balanced chemical equation. So the balanced chemical equation is already given in the question, which is calcium oxide plus 2 ammonium chloride gives 1 calcium chloride plus 1 mole of water plus 2 moles of ammonia, right? So over here, the amount of moles or the coefficient of calcium oxide is 1 because nothing is given, right? So from the balanced chemical equation, we can say that the amount or the number of moles of calcium oxide is 1. And for NH3, ammonia, it is 2. So we will be using this ratio method to find X. Now what we will do is we'll just crisscross it and equate it. So 0.02 into 2 will be equal to X times 1, which means X is equal to 0.04. X is nothing but the number of moles of NH3, right? So number of moles of NH3 is basically equal to the volume of NH3 divided by 24, right? That is the formula that we use to find out the number of moles of a gaseous substance. So NH3 being a gaseous substance, you can see that number of moles of NH3 is nothing but volume by 24, and we have to find the volume, right? So volume of NH3 will be 24 times number of moles of NH3, which is equal to 24 times 0.04, which equates to 0.96 centimeter cube. I hope you understood this. We are using this formula n is equal to volume by 24 because it is given that all the volume calculations are done at room temperature and pressure, and according to the molar gas volume at room temperature and pressure, the amount of a given gas will be 24. That is, the volume occupied by 1 mole of a gas will be 24 centimeter cube. That is why we are using 24 over here. So this is about this question. So I'll just summarize this question. So we wanted to find the volume of ammonia produced, but since ammonia is a gas, we know the formula for calculating number of moles of a gas is n equal to volume of the given gas divided by 24. And since we don't know n or volume of NH3, and we need to find the volume, so we use the stoichiometric ratio method to first find the number of moles of NH3. So in order to use the ratio method, we also need a reference molecule. So usually we will be taking the limiting reagent as the reference molecule. So the calcium oxide, which acts as the limiting reagent, is taken as the reference molecule, and we first find the number of moles of calcium oxide using the formula m by mr since it is a solid. And then we use the ratio method to find the number of moles of ammonia. So coefficient over here is nothing but the number that you see next to the given compound in the balanced chemical equation. Okay, so once that is done, once we find out the number of moles of ammonia, we use the formula n equal to volume by 24 to find the volume of gas, and we got it to be 0.96. Moving on to the next question. Deduce the formula of anion in Na2SO3. In order to find the formula of an ionic compound, we use the crisscross method, wherein we will be writing the cation, that is Na, and the anion is SO3. So we'll be writing the cation and anion separately, and then we'll be writing the charge of the cation and anion respectively. Over here, Na belongs to group 1, so it has a fixed oxidation state or charge, which is +1. For SO3, we don't know the charge, so we can put it as X. Now, in order to get the formula, what do? We just crisscross the charges and write the formula. So Na will have X as its subscript, and SO3 will have the charge of Na, which is 1. So since it is 1, we don't explicitly mention it. Okay, so whatever is the value of X, that is going to be the charge of the anion. So from our question, we can understand that X is going to be 2 because the formula of the compound is given as Na2SO3, which means X is equal to 2. Or the charge over here, that is charge of SO3, is going to be 2. So the formula of the anion is going to be SO3 with its charge, which is 2 minus. Okay, I hope this question is clear. We'll move. The next question says glucose C6H12O6 is made in plants from carbon dioxide and water. Write the symbol equation for this process. So this process is photosynthesis, and you will be studying about this process in detail in chapter 10. But since symbol equations are there in chapter 2, we'll be trying to solve this question as well. Okay, so carbon dioxide has a formula CO2, and water has a formula which is H2O. And whenever carbon dioxide and water reacts, it produces glucose and oxygen as a product in the process of photosynthesis. So the equation will be carbon dioxide plus water gives glucose, which is C6H12O6 plus oxygen. Now, this is not balanced. We will have to balance it. So if we look at the number of carbon atoms, there is 6 carbon atoms in the RHS and there is only 1 carbon atom in LHS. So we have to make it into 6 by multiplying this particular number with 6. Okay, so 1 into 6 will only give 6. So we'll write it as 6 CO2. So now if you look at the number of hydrogen atom, there are 12 hydrogen atoms in the RHS, but the number of hydrogen atom is only 2 in the LHS. So we have to make this 2 into 12 by multiplying it with 6, right? So if we multiply 2 with 6, then we will get the corresponding value in the RHS, which is 12. So we will write that over here, just 6H2O. Carbon and hydrogen is balanced. Now the remaining element is oxygen. Oxygen has 6 into 2, which is 12 in carbon dioxide, and 6 into 1, which is 6 in H2O. So total number of atoms of oxygen is 18 in the LHS. And in the RHS, we have 6 and there is 2 in oxygen, right? But we can't change glucose because if we try to add or multiply the number of atoms in glucose, then carbon and hydrogen will also get affected. So we can't add a number to glucose, rather we will add it to oxygen. So in order to make it 18, so 18 minus 6 will be 12. Now we have to have 12 oxygen atoms from this oxygen molecule. So we can get that by multiplying this oxygen molecule with 6. So it becomes 12 and the equation becomes balanced. So this will be the balanced chemical equation, that is 6CO2 plus 6H2O gives 1C6H12O6 and 6O2. Now let's move on to the next question, which says sulfur is a group 6 element. A sample of sulfur contains 2 isotopes, S32 and S34. State the mass of 6.022 into 10 raised to 23 atoms of S34. Include units in your answer. So 6.023 atoms of S34. What does that mean? What does this number mean? When there is 6.02 into 10 raised to 23 atoms, or any substance which is having a value of 6.02 into 10 raised to 23, we call it as Avogadro number or 1 mole of a substance. So over here, we have 1 mole of S34 atoms. 1 mole of any substance will have a mass that is mentioned on the top along with the element, right? So over here, the mass of sulfur is 34 and this 34 is for 1 mole. So 1 mole of a substance will have 34 grams. In your periodic table also, if you see the mass that is given in the periodic table, it is for 1 mole of a substance. So over here, we are having 1 mole of atoms of S34, which means the mass of S is 34. And since it is 1 mole, the substance will have 34 grams as its mass. Now, state the name of the amount of substance which contains 6.02 into 10 raised to 23 atoms. Just now, I told you that 6.02 into 10 raised to 23 atoms is called as 1 mole, right? So the name is 1 mole. With that, we are completing the questions related to chapter 3 from 2024 May-June series. I hope you understood. If you have any doubts, you can put it in the chat box. If you're having doubts related to the equations that should be used, you can check part 1 of the series, whose link I'll put it in the description. Thank you.